All right, pre-calc. Next step that we are going to be covering is the vertical shift. Okay, so this is something that we have done before. So I wanted to go back to an x squared function and just show you this step right here will be the vertical shift. This is where the graph is moved up and down, where we are adding or subtracting a value um, to mainly to the point that we are tracking, but it happens to every point on the graph. So we're going to start out, we're going to systematically graph this. So I'm going to start out with my parent function, f of x equals x squared. So this is, again, just a parabola, upward facing parabola like this, and we track the point 0, 0. All right, so keep in mind when we're doing these graphs, you need to have the equation, you need the graph, and the points, okay? When we're doing the sine, cosine functions, there are a lot of points that you need to track, but you have to make sure that all the points are there. All right, so what I'm going to do here is I'll first of all show you the steps that I'm going to follow. So the first step that I'm going to do is this -2. The next step is the -3. And then the last step, the +4. All right, and the +4 is actually the step that we will use this concept in our sine graph for today. All right, so first up is the -2. So f of x equals -2x squared. So you may remember that that number is the number that is multiplied by your y values. And this is just this is exactly the same process that we did with our amplitude. All right, so if we take all of these y coordinates from our previous graph and we multiply them by -2, there are two things that are going to happen. First of all, the negative is going to make it flip, so it's going to go down now. But then also the 2 is going to make it 2 times as tall. So in the x squared function, this basically just makes it look a little skinnier. So I'll show you real quick what this would look like on the same graph. So in the x squared function, we have the point 1, 1. So if we multiply that by 2, ignoring the negative for now, if we multiply that by 2, well, first of all, let's start at 0, 0 times 2 is still 0. But the next point at -1, 1, if we multiply that by 2, it's going to bring it up here to -1, 2. Same thing at 1, 1. If we multiply that by 2, it would be 1, 2. All right, so we can see here that if the graph is 2 times taller, it just makes it look skinnier. All right, so that's what it would look like on the same coordinate plane. All right, now let me just back up here for a second and do our graph here on the next coordinate plane. So again, 0, 0 is going to stay right there at 0, 0 because 0 times -2 is still 0. So my point that I'm tracking is still 0, 0. All right, but like I said, the negative is going to flip it down and the 2 is going to make it skinnier. So that is what our graph looks like for number 1. All right, number 2. Excuse me. Number 2. Now, in these graphs here, we did not do anything with what I'm referring to, not what I'm referring to, but what we just covered in the last set of notes with the period. And that's mainly because the number that's in front here is a 1, and we never covered any of the graphs where the number in front of the x is something other than 1, okay? But understand that it is a possibility. It's just not something that I covered, so we didn't really worry about that. So next up is the -3. This is actually the process that we will be doing on the next day's notes, where we are going to take this and this is called a phase shift when we're dealing with trig function. This is a phase shift. So in this one, we just called it a horizontal shift, and it's really the same thing for trig functions. It just has a fancy name. And but it's the same process. We had a -3, and that moves it left or right. And since it's a minus, that means it's going to move it to the right. Remember, the number associated with the x is the opposite of what we would think. So it's going to move it 3 units, but this is going to be 3 units to the right. So I'm going to say, here's my point at 3, 0. Still has the same look to it, but it's just shifted over 3 units. We want to make sure that we put our equation here so we can represent what is exactly happening. Okay, so the last thing is the +4. And like I said, this is a vertical shift. I don't know that we ever called it that, but this is how much the graph is moving up or down. +4 moves the whole graph up 4 units. So, exactly this exact same process is going to be transferred over to our process for today with the sine function. So, again, if you understand this, moving the sine function is pretty simple. So let me first of all start by drawing my coordinate plane. So I went over 3 for the x minus 3, and now the +4 is going to move this up 1, 2, 3, 4. So here is my new point. It is at the coordinates 3, 4. Excuse me, still has the same general look to it. All right, so again, this last step that I did here with the +4 is what we are going to be talking about today with the sine function. All right, so I added it to the list on the notes. So right here, again, you can see this was not here on the notes from 4, 4, 1, 2, or 3. So I added this extra part here. And the reason why I skipped over C is because C will actually go inside here, inside the parentheses when we do the phase shift. So we have A is the amplitude, B is the period, and D is the vertical shift. All right, so now we know that it's a vertical shift because it's a number being added or subtracted, and it's outside of the trig function, not being multiplied by the trig function out front or by the variable on the inside. So that's how we know it's a vertical shift, because it's out here, outside the parentheses, being added or subtracted. And just like in the previous example, adding is going to move it up, and a subtraction is going to move it down. All right, so and that's what I have this listed here graphically. The vertical shift is a number that moves the graph up or down. And you guys know this from before. Up is a positive, down is a negative. So I have 2 examples for us today, so we're just going to get into these. We're going to start out with the 1 period interval. And you can see I took out the other stuff. There's no A, there's no B. We're just going to focus on this for today. And then later on, we'll add everything else back in. So starting off with our parent function, okay? And remember, you need to show all of these parts in order to get credit. You need the equation, you need the points, and you need the graph. Okay, so you need to make sure that you're showing all of these parts. So here's our sine function. Parent function goes 1 down to -1. We start on the x coordinate at 0. We got our pi over 2. We got pi. We got our 3 pi over 2. And we got our 2 pi. And again, these are just your quadrantal angles from your unit circle. So let's change up the color. I should have did all that in black. I like to do the graphs in blue and red and just keep the coordinates the same color, but it doesn't matter. Okay, so sine starts at 0, 0. Pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0, again, back to where we started. So we go up, we go through our point, we come back down, and we go back up. There's your parent function. All right, so in our only step for today, we are going to add in this +3. All right, now, let me actually back up a step here. So if I do a +3, let's think about this. If I do a +3, what's going to happen to my values? Well, my highest value was at 1. But if I move that up 3, my highest value, 1 plus 3, is 4. All of these values that are at 0 are going to be moved up 3, so those will be at 3. And then all my values at -1, -1 plus 3 is 2. Okay? So we can see here that none of these values will be below the x-axis. That doesn't mean that we don't write the x-axis, because we still need it for all of our points. Let me write our points in here. Now, these points did not change, so we're going to recopy them. But again, you need to show these. All right, so let me scroll up a little bit so we can see everything. 3 pi over 2, and last one, 2 pi. Okay, so let me write the graph. Let me write the function. F of theta is equal to sine theta. And then we had the plus 3. And again, the plus 3 on the outside being added means the whole graph is shifted up 3 units. So let's track each of these points. All right, so again, pause the video while I'm going through it if you need to. Go step by step. I'm just going to keep running through it. Okay, so if you need to pause, then pause the video. So first up, my y-coordinate was at 0. So 0 plus 3 moves it up to 3. My second point at pi over 2 was at 1. So 1 plus 3 moves that point up to 4. My next point, pi, was at 0. And again, 0 plus 3 gives me 3. Next, we had 3 pi over 2. That was at negative 1. So if I do negative 1 plus 3, that's going to give me 2. And then my last point, 2 pi. Remember, 2 pi should always end where it started at 0 in the first graph, but here it's at 3. And again, we can see that if we take 2 pi 0 plus 3 gives me 2 pi 3. All right, so exactly the same process that we did there in the last graph of our bell ringer. It's just with a different function. All right, so there's your final graph for this one. That's what you should have. The last one here, we have a -4. So I just wanted to do one of each. And again, it's the same process. So if you understand it for one of them, you should understand it for all of them. All right, so starting out with the parent function, we're going 1 to -1. I'm going to make my line a little thinner here. Just makes it look a little nicer. So first up is pi over 2. Then we got a pi. Then we got a pi over, 3 pi over 2. That should be pi. And our last one is at 2 pi. So I'm going to start out with the parent function again. So f of x. And again, I've been mixing these up because you're going to see x's, you're going to see thetas. So, I just want to mix them up in the examples. So we're starting out 0. Again, if you've been doing all the notes, then you already know what these look like, and this is nothing new because you've seen all the notes. If you have not been keeping up with the notes, you need to go back and rewatch them so you actually know what's going on here. All right, so if you're confused on this, it's probably because you're not watching the notes and you haven't been keeping up with everything. So better late than never. Go back and get caught up on everything and make sure that you have all the notes caught up. This is day 4 of the notes, so if you missed the first 3, like I said, better late than never. Go back and do them now. All right, so I'm going to take this whole graph, and -4 means I'm going to shift it all down 4. So my first point from 0, well, 0 is going to get moved down to -4. My next point was at 1. 1 minus 4 is -3. So that's going to be shifted down to -3. 0 is at -4. 0 minus 4 is -4. And -1 minus 4 is -5. So right now with this graph, I don't have anything above the x-axis. But again, I'm still going to fill it in. All right, we still want to make sure that we have all of our values here. Okay, so starting off, our first point is at 0. Second point is pi over 2. And my next point is pi. Next up, we got 3 pi over 2. And our last point is 2 pi. So our function, f of x, equals sine of x minus 4. All right, so let's track each of these points, starting off with our first point at 0, 0. -4 gives me 0, -4. Next up, we had pi over 2, 1. 1 minus 4 is negative 3. Pi was at 0. 0 minus 4 means pi will now be at negative 4. 3 pi over 2 was at negative 1, and negative 1 minus 4 gives me negative 5, so that'll be down here at negative 5. And 2 pi, we have to end where we began, but again, if you start out at 0, minus 4 gives me negative 4. So we go up through our points, down here. Try to hit all your points. Mine are a little bit off right there, but we'll do that. We'll cheat a little. Okay, so again, your vertical shift is just the number outside parentheses, not with the x, being added or subtracted to our trig function, and this will move the graph up or down. Again, if it's a plus, it moves it up. If it's a negative, it moves it down. All right, so like always, if you have questions, please be sure to send me an email and let me know. I am available to answer emails or anything all day. I can also get on Google Meet or anything like that to answer any questions. So if there is something you're struggling with, please let me know. As we are going to build on this, we have one more day of notes on this. I'm going to take a day to go through everything that we've covered so far, and then we will cover the phase shift for the last graph. Okay, so just to make sure that you're keeping up with everything. If you haven't been watching the videos, go back and rewatch or watch them for the first time so that you can get caught up. All right, so again, like I said, let me know if you have any questions.